Welcome everyone to our virtual session for ArcGIS Analytics for IoT. My name is Suzanne Foss. I'm a product manager on the real-time GIS team here at Esri. And joining me for this presentation is Brian Watson, who's a product engineer on the Analytics for IoT team. And in this session, we're going to talk to you about a new capability that's been recently released for Esri's Geospatial Cloud, which allows users to license real-time and big data capabilities for their organization. So what we'll do first is go over a product overview of Analytics for IoT and then talk a little bit about some of the enablement paradigms for developers. I wanted to kick things off in our session with a little bit of context. As many of you no doubt well know by this point, we're already very much living in the connected world. And this has been true at the consumer level for many years in terms of smartphones, and more recently with other connected consumer products like lighting, home security, and even our appliances. It's estimated that by next year, there's going to be 20 billion connected things in the world. And a lot of these will continue to be consumer focused, but an increasing number, around 8 billion, will be used to support cross-industry or vertically oriented business applications. And there's a variety of reasons for this explosion in these connected devices and sensors. Sensor technology has become cheaper, which means that the devices are more readily produced and available, and more and more organizations are purchasing and deploying these sensors at lower cost. But these sensors and devices are also becoming smarter. So there have been devices and sensors for a long time that are able to record information about their environment. But now, with improved technology, devices are not only recording observations, but also able to make decisions on board and perform actions and trigger alerts based on those observations, as well as receiving commands from the cloud based on the information that they're collecting. And given that it's estimated that roughly 80% of sensor data has a location component, this lends itself to a wide variety of geospatial use cases. For example, real-time data from sensors about employee locations can be combined with information about the immediate environment around them to help keep them safe, but also to gain insight from movement analytics and help optimize their work and their allocation. More broadly, businesses of all types want to be able to monitor, manage, and optimize their assets. So whether that's a fleet of vehicles or valuable hospital equipment. Many organizations want to be able to leverage contextual data to protect critical infrastructure. This often has to do with detecting and responding in near real time to different sorts of feeds, such as weather and disasters, to locate and isolate areas or facilities at risk. In the utility space, there's SCADA integration and operations monitoring. In the agricultural and environmental markets, there's crop and air quality monitoring. In transportation, there's an increasing number of roadway sensor deployments to bring in data from connected cars. The list really goes on and on here. And in order to meet the demands of any of these use cases and really take advantage of the data produced by these sensors, you need to be able to do three fundamental things. The first is to ingest data being broadcast by sensors. The second is to be able to process that data in real time, often to trigger alerts and actions. And then the third is to store and analyze massive amounts of that observation data over time to reveal patterns that can provide insight for future decisions. And what we have seen at Esri is building systems that can do all of this for the high volume and velocity of data produced by IoT devices is challenging. Many of the use cases that we just reviewed revolve around mission-critical systems, and those types of systems need to be highly available, resilient, and scalable. And so ArcGIS Analytics for IoT is a capability that takes advantage of contemporary technology advances and extends Esri's Geospatial Cloud with real-time and big data functionality. It's a hosted managed SaaS that enables you to access, analyze, and act on any kind of observation data. Behind the scenes, it runs on a Kubernetes container-driven architecture. And what that means is that it can achieve levels of scalability and resiliency that we've never really been able to do before. The capabilities of Analytics for IoT are surfaced through a few new types of items in ArcGIS. Feed items allow users to receive sensor inputs. Real-time analytic items allow you to perform real-time processing of those inputs, including triggering alerts and actions. And with big data analytic items, users can access and analyze big data repositories of historical observations. Analytics for IoT is typically connecting to industry IoT cloud platforms or third-party repositories of data. It does not typically connect to IoT sensors themselves, although sensors could be configured to push data to Analytics for IoT over a REST endpoint. Now, the feeds and analytics that you configure are managed by the Analytics for IoT web application. Analytics for IoT is very much an engine. It's a system that runs real-time and big data jobs, and the app is an authoring experience for those capabilities. And the new item types, feeds, real-time analytics, and big data analytics, essentially map back to those three IoT challenges of ingestion, alerting, and analysis. So what we're going to do next is show you how this works in action. We'll begin with the real-time capabilities of the product and talk you through how you do real-time data ingestion and analysis of IoT data. And for that, I'm going to hand things over to Brian.
Thanks, Suzanne. I'm going to walk through creating a feed, the new ArcGIS Online item type for working with real-time data. Now I can bring data in from a variety of real-time data sources. I can connect to an ArcGIS feature or stream layer, a cloud service like Amazon AWS or Azure, or a web and messaging service. For example, I could pull a website, send data to a dedicated web server endpoint in Analytics for IoT, or connect to a messaging broker like Kafka or MQTT. For this example, I'm going to connect to an Azure Event Hub that is streaming simulated bus locations played back from real historical data. So I'll go ahead and go over to the cloud section and find the Azure Event Hub feed type. Now I just need to enter some connection information. I'll go ahead and do that. Now when I click Next, Analytics for IoT is going to test the connection to that Azure Event Hub, then try to sample data and derive the schema of the data all in one step. So let's go ahead and do that. As we can see, Analytics for IoT was successful. The data looks to be in JSON format, and over here I have the field types and the field names it was able to derive from that JSON data. On the right here I have the samples that were used to derive the schema. This all looks good. I just want to make a few minor changes here. I'm going to make the time field a better name, and then I know I don't need this final field, so I can go ahead and drop that. Okay, everything looks good now, and I'll proceed. Now I need to set a few key fields here so we can properly construct ArcGIS features. First is the location. Now I have a few different options here, a single geometry field or X and Y fields. Now if I look back at the data, I can see I have two separate fields, so I know I can use X and Y fields. So I'll go ahead and select that. It was able to automatically detect those fields based on the name, and now I'll just set the spatial reference. Next, I'll set the time field that I had, and that's a numeric field, so I'll set that. And next is the track ID. The track ID is just a unique identifier for the data coming in. And for that, we'll pick the bus route ID. I can go ahead and proceed to the next step. And here I just need to give a name and an optional summary. So we'll go ahead and set the name and a summary. From here, we can review the details of the feed we just created, including connection and data format details, as well as geometry of the feed and the schema of the attributes. Now I also have some actions I can take here as well. I could edit the feed in case something about the data or the connection property changes. I could clone it if I wanted to create a duplicate. I could add this feed to a new analytic to do further analysis. I could go to the item details page in ArcGIS Online. Now, feeds behave like a type of stream layer, so they can be easily visualized as well. And so I'll go ahead and open this feed in a new web map. So I know this is in the Charlotte area, so I'll go ahead and zoom in there. Now, as we can see, we can immediately visualize and begin interacting with the data coming in. Now I'm ingesting and bringing this data in, but I may want to do further analysis, and for that we'll need to create a real-time analytic. Now I have several real-time analytics here. To show how these work, we'll build one up quickly. I'll put together a simple analytic that geofences and detects any connected car data in work zones and sends those results to a new stream layer. Now let's go take a look at the data. As we can see, I'm in the downtown Charlotte area. I have some sample work zones highlighted here. Now I also have a connected cars layer. Again, I want to see what cars enter these work zones. But first I want to make sure the data I'm detecting is only accurate data, so I'll do a filter on that as well. Let's go back and create this analytic. I'll go ahead and begin the authoring process, and I'll select an existing feed we have already, that connected cars layer we were just viewing. And now I could begin creating the analytic right here by selecting from a number of tools. First, I'll save this analytic because I know it's one we'll want to keep. As you can see, the interface has changed a little, and now I have some warnings up here. This is telling me the analytic can't be run until I resolve these issues. We'll do that next. As I'm building this out, you'll notice Analytics for IoT is constantly checking the analytic to see if it is valid and can be run. The first thing we want to do is filter out any of that data that has poor accuracy. So I'll go ahead and do that by adding a filter by expression tool. As you can see, Analytics for IoT has a built-in arcade expression builder, so you can build custom logic into your analytic workflows. Here I'm just going to create a simple expression to keep data with an accuracy of less than 20 meters. I'll go ahead and apply that. Now that I have only high accuracy readings, next I'll need to add my spatial filter. So let's go ahead and do that by adding our filter by geometry tool. First, I'll define the dataset used for the filter. For that, I'll add the work zones polygon feature layer we saw on the map earlier. Now I have some options. I could filter out some of the work zones if I wanted to, but I'll leave this as is to bring in everything. And I'll just set a track ID to our zone ID. Then I just set my spatial relationship to intersects and apply. And we see I still have a validation warning that I need to add an output. So let's go ahead and do that. And for that, I'll add a stream layer. In this first step, I can set a related feature layer. This is typically used for stationary sensor scenarios where the data is being sent without geometry. So I'll go ahead and skip this and give this layer a name. As we can see, Analytics for IoT immediately validated this. Now I have the green check mark that says this is ready to run. I'll go ahead and start this. While this is starting, it's important to highlight Analytics for IoT has two views to author your analytic. We've been working in Workflow view, which is typically used for more simple analytics. Alternatively, I can switch to Model view to use a familiar flowchart-like builder. When analytics become complex with multiple pipelines, the application will disable the Workflow view, and analytics can then only be authored in the Model view. Now that this is run for a little bit, I want to go find my stream layer output and view it in a map. There are several ways I could do that. I could go to the Layers page in Analytics for IoT. I could go to the node and open this in a new map. I could also go to ArcGIS Online and search for this layer from there. Let's go ahead and do that. And then I can go ahead and add this to the map. As we can see, we've gotten some detections here. And all of them have the accuracy we're looking for. In summary, in Analytics for IoT, we can ingest real-time data from a variety of sources to create ArcGIS features using feeds. These feeds can easily be added to web maps to begin visualizing your spatial data, as well as to real-time analytics to do further analysis on that data in real time.
Thanks very much, Brian. So just to recap some of the concepts that you saw in the demonstration, in many ways, ArcGIS Analytics for IoT's capabilities begin with a feed, which is ingesting real-time sensor data. Feeds typically connect to external sources of observational data, like Internet of Things platforms, message brokers, or third-party APIs. Feeds, in their essence, parse incoming data, whether it's tabular, point data, polyline, or polygon data, and they expose it for analysis and visualization in ArcGIS, like Brian said, creating ArcGIS features. And a feed is also a type of stream layer, and it can be added to a map to see new information as soon as it's received. And then you can use feeds in real-time analytics to do processing and alerting. A real-time analytic is a long-running job that continuously operates on data coming in from the feed, transforming it, enriching it, detecting incidents, and then taking action. Real-time analytics can also bring in data from static data sources to be used for enrichment, geofencing, and data joins. And then within a real-time analytic, you can combine different tools together in a workflow to ask any number of questions and associate different output behavior with each question. Real-time analytics are useful when your decision timeline is operational, so when you need to know about something and take action immediately. Next, we're going to take a look at how you work with observational data over time in analytics for IoT using big data analysis. And for that, I'll hand things back over to Brian.
Thanks, Suzanne. Big data analytics are constructed pretty much the same way as real-time analytics. So in the interest of time, I'm just going to show an example of one that we already have built out. In this case, we're going to work with Waze data. Now, in another real-time analytic, we are collecting this Waze data and storing it in a feature layer. And so, of course, with this, we can ask questions of the data over time. Let's take a look at that data. Now, local governments today are already using Waze information for all kinds of purposes, from traffic situational awareness to pothole detection and triggering service jobs to fix them. By looking at data like this over time, it can of course be used to summarize and establish patterns that can improve decision making. This big data analytic brings in the collected Waze alerts, filters them for traffic jams, and at a high level summarizes them by street segment. We do this by first doing a simple query on our feature layer to get just the traffic jams. And then we calculate the distance to the nearest road segment, so we can get the closest road segment to that traffic jam. And then from there, we do a simple join with that data to the streets. This is a join of roughly 200,000 features against 200,000 line features. Now let's look at the results in a map. The results in this case show us the street segments that see the most traffic jams over this time range. But we could just as easily summarize this using hour of day or do additional time series analysis to identify patterns that we would not be aware of. And along those same lines, generate rich training data that could be used in machine learning models. So these big data analytics can certainly be used to detect different types of incidents, but also as a way to summarize and prepare data for predictive analysis. Later this year, we'll also be bringing some of these machine learning tools directly into analytics for IoT to support end-to-end predictive workflows with IoT data.
Thanks very much, Brian. So again, to recap, big data analytics analyze data that you store over time. In many cases, data that you may have stored using a feed in a real-time analytic. A big data analytic is a specific job that fires up, runs on the designated stored data, analyzes trends, and then pushes out results. It's like a real-time analytic in that you combine different tools together, but in a big data analytic, you work with stored information as opposed to real-time data. And it's important to note that the same outputs are available for big data analytics, so you can take automated action in your IoT system based on overall system status. So big data analytics are useful when your decision timelines are tactical, when you need to make a decision regularly based on standard practices, or they're useful when your decision timelines are strategic, when you need to learn over time and adjust broader policies. The spatiotemporal analysis offered with Analytics for IoT is varied and largely aligns with the tools available through geoanalytics. We've partnered with the geoanalytics team to leverage their algorithms as is and run them in the Analytics for IoT environment. There are also some additional tools here that are specifically oriented for tracking and pipeline building workflows. For example, Calculate Journeys is a tool unique to Analytics for IoT that allows you to divide up track-based data into polyline features where an entity was moving and point features where an entity was staying still. There's additional tools as well, like doing simple filtering, mapping schemas from one form to another, selecting to retain certain fields as opposed to others, and merging different pathways in an analytic pipeline together. These are particular to Analytics for IoT because they're specifically geared towards building models and having an analysis conducted over a multi-step process. All of these tools that you see here work in big data analytics, and those that can operate on a single message at a time will also work in real-time analytics. And what we mean by that is that some tools like Calculate Fields can operate on a single message, calculating the new field on that single message and continuing that message down the pipeline. And other tools by their nature are meant to operate on a set of features at once. So for example, Find Hotspots by its nature is finding global averages across a set of data. And you would never run Find Hotspots in real time because you don't find hotspots on a message individually. More and more of these tools will be adapted to work in real-time analytics over time. So that rounds out the product overview for today. Analytics for IoT, while very suited for sensor observation data, more generally brings real-time and big data capabilities to Esri's Geospatial cloud. And these capabilities can be summarized in these 6 categories: ingestion of data, visualization, which is in terms of both the real-time layers and the dynamic aggregation layers, analysis, especially in terms of geofencing, incident detection, and trend assessment. And lastly, Analytics for IoT offers alerting and the automation of output actions, including talking back to external systems. Next, let's talk about this product in the context of developer enablement. In the current release, there are opportunities for developers in 2 major areas. One primary way developers can engage with Analytics for IoT is working with the output products in custom applications. As we've discussed, Analytics for IoT offers a SaaS solution for bringing different types of data streams into ArcGIS and then producing output information products like stream layers, feature layers, and map image layers. As a developer, you can include these layers in custom applications that enable situational awareness and data exploration. So 2 things to note here. Feeds and stream layers display real-time data in a continuous streaming paradigm, where data is being pushed to the map immediately upon being received. And in the new 4.12 JavaScript API, the performance of these layers is vastly improved, enabling your applications to render thousands of unique data points more seamlessly, and providing new rendering options for de-emphasizing and automatically removing older data. Secondly, when you store incoming data with Analytics for IoT, every feature layer supports the same on-the-fly aggregations as that associated map image layer. In a custom application, the rendering capabilities for these dynamic aggregations are much broader, and you can develop experiences that are tailored to the data at hand, adjusting the representation of the information automatically based on what the user is doing. The other paradigm to discuss is systems integration, for those of you who specialize in extending or automating the ArcGIS platform. There's one very central integration opportunity here in terms of data integration. Analytics for IoT can't support directly every possible sensor vendor out there. So there's an opportunity, especially by industry, to build and offer cloud-based external connectors that get sensor data from the source and make it available in one of the compatible feed types in Analytics for IoT. Analytics for IoT in the current release supports a variety of different types of input streaming data. So the feed types include bringing data in from a feature layer, receiving data from IoT cloud platforms like Azure and AWS, polling for data, which would support different third-party APIs, and a number of message brokers as well. But there can additionally be external cloud-based functions that translate data from even more sources into one of these compatible feed types, and that is an opportunity for developers with this product. Likewise, the same could be done for input sources of static data and for writing to different types of outputs. I wanted to bring up this data integration option first because direct integration with Analytics for IoT is somewhat more limited. As a SaaS, Analytics for IoT is not directly extensible, the same as how you cannot extend ArcGIS Online directly. That said, also like ArcGIS Online, there will be an automation API to enable creating and updating feeds in Analytics, starting and stopping them, getting status and logs, and other similar activities, which would enable a broader set of downstream applications later on. This automation API will be coming out later this year. And on this topic, we also wanted to note that under consideration for down the line is an offering for ArcGIS Enterprise. In this paradigm, Analytics for IoT would be a software product as opposed to SaaS and integrate with Portal for ArcGIS. And in this paradigm, we could support an SDK. As we wrap up, I also wanted to cover how licensing works. Analytics for IoT is offered as an annual subscription on top of ArcGIS Online, and it's purchased for each organization individually. It's also an overall capability for an organization. It supports several simultaneous real-time and big data use cases or missions. It's not sold by the number of named users because the underlying compute capacity needed in Analytics for IoT is really more directly related to those use cases and the data velocities as opposed to the number of users. So what does this mean for ArcGIS users? As we've seen, Analytics for IoT is managed by a web application, and this is an authoring environment for the new real-time and big data items. This web application is available to any creator or GIS professional user in the organization. And the app is what allows you to do the things you saw in the demonstrations, configure a feed to receive sensor observations, configure a real-time analytic to process those observations, detect incidents, and send alerts. Now, So this application is available to any creator or GIS professional, but it is governed through privileges. So your administrator will have control over who can access Analytics for IoT and create these processes. Now, the analytics that these users author and run can generate different types of output products, like stream layers, feature layers, and map image layers. And these are available to all users in the organization to monitor, explore, and use in ArcGIS client apps. So Analytics for IoT is a real-time and big data capability for the organization, likely managed by a few, but making IoT insights and decision-making available to everyone. And as a subscription, Analytics for IoT follows the same business rules and policies of ArcGIS Online, meaning its end date will typically align with your overall subscription end date, renewal activities will happen together, and so on. With that, we'll go ahead and wrap up here. ArcGIS Analytics for IoT brings real-time and big data capabilities to Esri's Geospatial cloud, hosted and managed for you so that automated data ingestion and analysis is easier than ever before. Thanks very much for joining us for this session, and don't hesitate to reach out to us if you have questions. Thank you.